Good morning, everyone. I'm Sir Marlon Revidizo and welcome to our Grade 9 Math. Today, we are going to study about simplifying radical expressions.
For our objectives, we're going to simplify radical expressions by reducing the radicand, reducing the order of the radical, and rationalizing the denominator.
Now, let us simplify radicals by reducing the radicand.
Let's have the first example. We're going to simplify a radical expression by reducing the radical of square root of 75. We can use prime factorization. 75 can be factored as 3 and 25, and 25 can be factored as 5 and 5. So, the prime factors of 75 are 3, 5, and 5.
Using prime factorization, we have to consider the index to group the prime factors before taking it out from the radical sign.
We are going to get a pair of same numbers, and that is 5 and 5. And taking that out of the radical, so we will have 5 square root of 3. Another way is by perfect square factorization. But first, we have to be familiar with the perfect squares. They are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and so on. The factor of 75 wherein one factor is a perfect square is 25 and 3. And the factors can be written separately as square root of 25 times the square root of 3. Since 25 is a perfect square, so we will have 5 square root of 3. As you can see, both solutions have the same answer. Another example is square root of 72. And rewriting that inside our radical sign, so we will have 2 times 2 times 2 times 3 times 3. Again, since we get the square root, we have to group prime factors with a pair of same number, and that is 2 and 3. And taking that out of the radical sign, we will have 2 times 2 is just 2, and 3 and 3 is 3, then square root of 2. Then simplifying 2 times 3, that will give us 6 square root of 2. This time, let's use perfect square factorization. Let's take another example. Cube root of 40. Using prime factorization, the prime factors of 40 are 2 times 2 times 2 times 5. Since our index is 3, we are going to group prime factors, 3 same numbers as one group. And taking that out of the radical, so we will have 2 cube root of 5. And using perfect cube factorization, we have to consider the factors that are perfect cube. And they are 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000, and so on. Cube root of 40 can be factored as cube root of 8 times 5, and can be written separately as cube root of 8 times cube root of 5. Since 8 is a perfect cube, we're going to get its cube root, and that is 2, then copy 3 cube root of 5. Now, let's have some example with variables. 98 can be factored as 49 times 2, and x raised to 4 can be factored as x squared times x squared. Same with y raised to 8 can be factored as y squared times y squared times y squared times y squared. As you can notice, we factored the variable with the exponent same as our index. And getting the square root of 49, so we have 7. Square root of x squared, so that is x. And same with the square root of y squared, so we have y. So our answer is 7x squared y raised to 4 square root of 2. Another way of solving this example is by factoring 98, which is 49 times 2, and dividing the exponent of the variable to the index. The exponent of x is 4, and since our index is 2, so we will divide 4 divided by 2, so that will give us 2. Then 8 divided by 2, that will give us 4. Then simplifying our answers, 7x squared y raised to 4 square root of 2. What if our exponent is not divisible to our index? For this example, we're going to factor out the variable wherein one factor can be divisible to our index. A raised to 4 can be factored as a cubed times a, and b raised to 11 can be factored as b raised to 9 times b squared. The exponent of a, 3, is now divisible to our index, same with the exponent of b, 9. So 3 divided by 3, so that will give us a raised to 1, or simply a. Then b raised to 9, 9 divided by 3 is 3. Then let's copy the factors that has no cube root, and that is cube root of ab squared.
And now, let us simplify radicals by reducing the order of the radical.
Let us solve 6th root of b squared. Step number 1, write the radical as rational exponent, and 6th root of b squared can be written as b raised to 2 over 6. Then let us reduce the rational exponent to lowest term. 2 over 6 can be written as 1/3. And now let us write the rational exponent as radical. So b raised to 1/3 is equal to cube root of b. Let's have another example.
This time, let us simplify radicals by rationalizing the denominator.
Our next example is square root of 3 over 2. As you can notice, our radicand is in the form of fraction. Our first step is express as quotient of two radicals, and square root of 3 halves can be written as square root of 3 over square root of 2. Multiply the fraction by a radicals, which will make the denominator perfect square. We are going to multiply square root of 3 over square root of 2 by its denominator, which is square root of 2 over square root of 2. And we will have the answer of square root of 6 over square root of 4. And now let us simplify. So we will have square root of 6 over 2.
And that is our lesson for today. I hope you learned something. Happy learning!